After engineers managed to fix their Voyager 1 probe, it was a big task. The retired Canadian astronaut Chris Hadfield described it like this.
A four-planet grand tour of the outer solar system: Jupiter, Saturn, Uranus, and Neptune.
In the cold silence of interstellar space, more than 15 billion miles from Earth, NASA's Voyager 1 probe, launched in 1977 and now traveling far beyond the reach of any other human-made object, has just made a startling discovery. The aging spacecraft, equipped with scientific instruments originally designed for a planetary mission, has once again proven its worth by detecting something truly unimaginable. For decades, Voyager 1 has relayed data from the outermost edges of the solar system and into the uncharted regions of the interstellar medium. Now, it has picked up signals and measurements that defy current understanding of what exists in the space between stars. The revelation is sending ripples through the scientific community and may fundamentally shift how humanity perceives the nature of the cosmos. Before we start, hit the like and subscribe buttons for more exclusive news. Voyager 1's latest discovery centers around a previously undetected anomaly in the interstellar plasma environment. Using its plasma wave subsystem, Voyager 1 identified a persistent and coherent signal unlike any ever recorded in deep space. The signal is not a random burst or an isolated emission, but an ongoing low-frequency oscillation that seems to emanate from a structured, coherent source. What's truly staggering is that this anomaly doesn't match any known physical phenomena. It isn't consistent with cosmic rays, background radiation, or even the expected turbulence in the interstellar medium. This is not a fluctuation or a transient echo. It's a continuous pulse that suggests the presence of an unknown force or mechanism operating far beyond the heliosphere. The sheer existence of this pulse raises profound questions. One theory proposes that Voyager 1 has stumbled upon a new type of plasma structure, perhaps an organized field or lattice that exists naturally in interstellar space but has never been observed until now. This idea challenges existing models of interstellar matter, which have long assumed that plasma outside the solar bubble is largely homogeneous, chaotic, and shaped primarily by distant stellar winds. If the pulse does indeed point to an organized structure, it would imply a level of coherence and complexity in interstellar space that scientists never predicted. Such formations could have enormous implications for theories about star formation, galactic evolution, and the underlying architecture of the universe. Another possibility that's gaining traction is even more extraordinary. The pulse may be artificial in origin. While scientists remain cautious, some researchers are exploring the hypothesis that this signal might be a product of intelligence, perhaps a beacon, a navigation aid, or even a form of interstellar communication. The frequency and modulation of the signal don't resemble any known natural source, and its consistent patterning evokes a sense of intentionality. If this is the case, Voyager the 1st of May have crossed into a region of space where another civilization, perhaps long extinct or still active, left a trace of its presence. The implications of such a discovery would be staggering. It would not only confirm that humanity is not alone, but also suggest that intelligent life has been active in interstellar space for longer than previously imagined. Regardless of its origin, the signal's properties are forcing scientists to revisit long-held assumptions about the boundaries of the heliosphere and the nature of interstellar space. The heliosphere, a vast bubble created by the solar wind, was thought to be a relatively clean boundary. Voyager 1 crossed this barrier in 2012 and has since been operating in the interstellar medium. However, the signal suggests that the boundary may be more porous and interactive than previously thought. Some researchers believe that there might be transitional zones or regions of hybrid physics, neither fully solar nor fully interstellar, in which new and unexpected behaviors can emerge. These zones might host exotic interactions between cosmic particles, magnetic fields, and plasma waves, giving rise to phenomena that were previously considered impossible. Adding another layer to the mystery is the fact that Voyager 1's instruments were never designed to detect phenomena of this kind. The probe is operating decades beyond its expected lifespan, with only a few functioning instruments still active. That such a monumental discovery could be made with aging technology speaks volumes about the precision and durability of the Voyager design. It also raises tantalizing possibilities about what more advanced probes, equipped with modern sensors and AI-driven analysis tools, might uncover if sent into interstellar space. This discovery could well be the harbinger of a new era in space exploration, one that looks beyond planetary boundaries and dares to probe the deep fabric of the galaxy itself. The timing of the signal's detection also adds to the enigma. For years, Voyager 1's data has been largely uneventful, filled with routine measurements of cosmic rays and magnetic fields. Then, abruptly, the plasma wave instrument began registering the strange pulse, an anomaly so distinct and sustained that it immediately stood out against the background noise. It's as though the probe crossed an invisible threshold, entering a region of space unlike anything encountered before. Scientists are now poring over years of Voyager 1's archived data to see if there were earlier hints of this phenomenon that were overlooked, or whether this region of space truly represents a new and unprecedented frontier. Complicating matters further is the spatial context of the discovery. Voyager 1 is currently moving through a region of space thought to be relatively featureless, a vast emptiness between solar systems where matter is sparse and radiation levels are low. The presence of a structured or coherent signal in such a region suggests that interstellar space may not be as barren as previously assumed. There may be dynamic processes at play that remain invisible to Earth-based observatories and even to other deep space missions. If the signal represents a recurring feature of interstellar space, it could mean that our galaxy is laced with hidden networks of energy, resonance, or even information, networks that humanity is only now beginning to detect. There are also broader implications for the search for extraterrestrial intelligence, SETI. For decades, SETI has focused on monitoring specific frequencies and regions of space, primarily using radio telescopes aimed at nearby stars. Voyager 1's detection suggests that vital signals might be hiding in plain sight, not beamed toward Earth, but waiting quietly in the vast distances between stars, detectable only by probes that physically enter those realms. This shifts the paradigm of how and where scientists should be searching. It suggests that passive exploration, sending probes far into space with sensitive instruments, may be just as important as active listening from Earth. Some theorists are even speculating that the signal could be a form of ancient technology. If it's artificial, it might originate from a civilization that existed millions or even billions of years ago, and whose remnants are still echoing through the cosmos. In such a scenario, the pulse might be a legacy artifact, a kind of cosmic lighthouse, broadcasting a message or maintaining a presence in the galaxy long after its creators have vanished. This raises the astonishing possibility that the galaxy might be filled with such artifacts, each lying dormant in interstellar space until a passing probe, like Voyager 1, triggers a reaction or picks up the signal. If so, then Voyager 1 has just become the first in a new kind of archaeological mission. A dig not into Earth's ancient past, but into the deep time of the cosmos. Even within more conventional scientific frameworks, the implications are vast. The properties of the signal might lead to revisions in the understanding of cosmic magnetism, plasma turbulence, or the life cycle of interstellar clouds. Some astrophysicists are theorizing that the pulse may arise from a previously unknown interaction between cosmic rays and interstellar plasma, possibly linked to galactic-scale phenomena such as magnetic field lines that span thousands of light-years. If that's the case, then Voyager the 1st of May have stumbled onto a phenomenon that connects different regions of the galaxy in ways that were never anticipated. The data is also challenging current instrumentation on Earth. Scientists are scrambling to simulate the conditions detected by Voyager 1, but the tools available in terrestrial laboratories cannot yet replicate the extreme low-density plasma environment of interstellar space. This has led to a surge in interest in developing new types of simulators and detectors that can model or capture the kind of waveforms Voyager has recorded. In a very real sense, this single discovery is driving innovation not just in space science, but in material science, computational modeling, and data analytics. There is also a psychological and philosophical dimension to the discovery. Voyager 1, a tiny fragment of human civilization, is now serving as an ambassador in a realm that defies understanding. It's relaying information from a place that no human has ever seen and likely will not see for many generations. The fact that such a probe could encounter something so profoundly strange reinforces the idea that the universe remains vastly unexplored, filled with phenomena that challenge the limits of imagination. This moment, this signal, reminds humanity that despite all scientific progress, the cosmos still holds secrets more alien and more beautiful than any fiction. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us? What are your thoughts on Voyager 1's new discovery? What do you think it detected? We want to hear from you. Thank you for watching and see you next time.